Greetings and salutations, everybody. This is Jacob. Okay, so how the heck do we put the kibosh on this problem? Smoke is coming out of my ears, you say. Worry not, my friends. This problem will be pushing up daisies pretty soon. No one will leave this video still wondering what the heck is going on. Oh no, not on my watch. Or you probably ran through this problem like a hot knife through butter and just want to confirm your solution. Or maybe you didn't give the problem a shot and just want to see the solution. Regardless of what camp you belong to, let's just get this show on the road, shall we? Oh yes. So the problem is asking us for the area of this shaded region here. Pretty self-explanatory. But how do we go about finding it? That's a whole different animal. Let's just start out by naming the radius of the second biggest circle, R1, and the radius of the smallest circle, R2. So this line segment here is equal to this line segment, since both are the radii of the biggest circle, correct? Since AC equals 5 from our initial conditions, then this line segment is R1 plus 5, and since AB equals 6 from our initial conditions, then this line segment is R2 plus 6, and since these line segments are equal, then we have R1 plus 5 equals R2 plus 6, correct? So we solve for R1, and we get R1 equals R2 plus 1. And this is our first equation. Since we have two unknowns, we need one more equation. So now let's take a look at the line segment BC. If you look closely, then BC is pretty much R1 plus R2, correct? And since BC equals 9 from our initial conditions, then we have R1 plus R2 equals 9, and that's our second equation. We substitute the first equation into the second equation, or vice versa, however you want to do it. And we get R2 plus 1 plus R2 equals 9. And we solve for R2 and we get R2 equals 4. And R1 equals R2 plus 1, which is 4 plus 1, which is 5. So we found the radii of the smaller circles. Now what do we do? So now we compute the total area of the triangle ABC using Heron's formula, which is this right here. Since we know all three sides of this triangle, so S equals 6 plus 5 plus 9 over 2, which is 10. And we plug in all our parameters in our formula, and we get area of the triangle equals square root of 10 times 5 times 4 times 1, which is the square root of 200, which is approximately 14.14 square units. Okay, next order of business is to find all three of these angles. We'll call them theta, phi, and psi. We'll start from phi. We'll use the law of cosines to find phi. So we have AB squared equals AC squared plus BC squared minus 2 times AC times BC times cosine of phi, which is 36 equals 25 plus 81 minus 2 times 5 times 9 times cosine of phi, which is 90 times cosine of phi equals 70, which is cosine of phi equals 7 over 9, and phi is our cosine of 7 over 9, which is approximately 38.94 degrees. Now to find psi, we'll use the law of sines, and we have AB over sine of 38.94 equals AC over sine of psi, which is sine of psi equals AC times sine of 38.94 degrees over AB, which is 5 times 0.62 over 6, which is 0.52. And psi is arc sine of 0.52, which is approximately 31.33 degrees. And theta is 180 minus 38.94 minus 31.33, which is approximately 109.73 degrees. So we found all these three angles. Next order of business is to find the area of these circle sectors here. Oh yes. The sector area of the bigger circle is phi times pi times r1 squared over 360. So we plug in our parameters and we get 38.94 times 3.14 times 25 over 36, which is 8.49. And the sector area of the smaller circle is 31.33 times 3.14 times 16 over 360, which is 4.37. So now that we found the sector areas, now we can find the area of this irregular shape here. We'll call it A1. And A1 equals the total area of the triangle minus sector area 1 minus sector area 2 which is 14.14 minus 8.49 minus 4.37, which is approximately 1.28 square units. Okay, so next order of business is to find the total area of this sector here, of the biggest circle. And we'll use the formula of the area of a circle sector again. And since the radius of the biggest circle is 10 units, and theta equals 109.73, then we have sector area B of the biggest circle equals 109.73 times 3.14 times 100 over 360, which is approximately 95.7 units squared. Okay, next order of business is to find the area of these semicircles here. The area of the bigger semicircle is SE1 equals pi times 5 squared over 2, which is 39.25. And the area of the smaller semicircle is SE2 equals pi times 4 squared over 2, which is 25.12. So now we're prepared to find the area of the shaded region. Oh yes. The area of the shaded region is AS equals S of B minus SE1 minus SE2 minus A1. Which is 95.7 minus 39.25 minus 25.12 minus 1.28, which is approximately 30.05 square units. And that's all she wrote, my friends. That's your answer. Oh yes, 30.05 square units. What you expected or out of left field? Let me know in the comments. So that was an interesting geometry puzzle, wasn't it, my friends? This puzzle's bark is certainly worse than its bite, for sure. Not as hard as it looks. It's like the neighbor's dog, which is small as heck and just barks incessantly, but can't hurt a fly. Oh, he is. You know, I was thinking of beefing up this problem a bit, or posting a harder one, but I decided against it, because I have some mind-bending puzzles chomping at the bit to being let out of their cage anyway. So I need some moderate problems here and there to keep things balanced. You know me by now, my friends. You know how this channel rolls. I know you guys are waiting for that other shoe to drop. Well, that shoe is gonna drop pretty soon. In the next video, in fact. So brace for impact. Yes. I have a beast of a problem waiting to be unleashed. So let me know in the comments if you liked this puzzle, if you found it difficult, if you solved it another way, upside down, for example. By the way, I know one of you made a suggestion for a differential equations problem. I gave it a shot, by the way, but quickly found out that there are no closed form solutions. I'm going to have to modify your suggestion a little bit, my friend. The one where a boat is pursuing another boat that is moving in a parabola. I'm going to have to modify it slightly. The boat being pursued maybe should be moving in semicircles, for example. Is that okay with you? Okay, that's pretty much it, my friends. Smash those buttons like your life depended on it. And I'll see you guys in the next video. Bye-bye.